Today is day 2 of our series on polygons. We're going to talk about the interior and exterior angles of polygons. And we're going to use the information about a polygon we've already talked about, and that is the triangle. And we know that it has its interior angle summed to 180. So we're going to use that information to try to come up with a formula. This first one is a quadrilateral. And a quadrilateral, if I take one vertex and I draw all the diagonals I can from that one vertex, I notice that I have two triangles. So if I have two triangles, 2 times 180 equals 360 degrees. The next one's a pentagon. Starting at one vertex, and I draw in. Here I had 2 triangles. Here I have 3 triangles, so I have 3 times 180, which gives me 540 degrees. And this last one that I have here for my example is a hexagon. One vertex, draw on the diagonals, and I have 1, 2, 3, 4 triangles. So 4 times 180 would give me 720 degrees. So we use this information and the information I know about finding a function, and I'm going to let n be the number of sides and s be the sum of the interior angles. So I know if I have 3 sides, I have 180 degrees. 4 sides, I have 360 degrees. 5, I have 540 degrees. And 6, I have 720 degrees. So I find my rate of change, and my rate of change in sides is 1, and my rate of change in the number of degrees is 180. And since it's a constant change, I know that it's a linear function. So I can go ahead and set that up. I know that the sum of the sides equals 180 times the number of sides plus some number. But I need to know what that number is. So what I'm going to do is I'm going to plug in one of these points I already know and solve for it. So I know that if I have 4 sides, then it equals 360 degrees. So I'm going to use that to figure out what this number is. 180 times 4 is 720. And if I subtract 720 from each side, I get negative 360 as my y-intercept. So my equation, or my function, would be the number of sides equals 180 times the number of sides minus 360. But when we use this formula, we actually simplify it a little bit more in that the number of degrees, the sum of the interior, is 180 n minus 2. And I got that by dividing 180 out of both of these. And so this is an equation that we're going to use a great deal. This 180 times the number of sides minus 2. So let's use that information to solve some problems. This first one is asking us to figure out the measure of this angle. Well, first we have to find out what all of the angles measure out to be. So we have 1, 2, 3, 4, 5 sides. So we have 180 times 5 minus 2, which equals 540 degrees. So the sum of all of these angles is 540 degrees. So we're going to add up the ones that we have here. We have 95, 155, 107, and you should do this with me. Remember, math is not a spectator sport. And if I add these numbers up, I get 455. So 455 of the degrees are accounted for. So to find the missing side, I take the total number of degrees minus the ones I already know I have, and so the missing angle is 85 degrees. Okay, now let's try this backwards. If we know how many degrees we have in the triangle, then we should be able to work backwards to find out the number of sides. So the formula says S equals 180 n minus 2. So the total is 1,260 equals 180 n minus 2. Divide both sides by 180, and I get 7 equals n minus 2. Add 2 to both sides, and 9 equals the number of sides, which makes this a nonagon. Okay. Try this one. Have the substitute pause it for a few minutes, and then after you've tried it, let's come back together and you can see how it works. Start with our formula, plug in what we know, divide by 180, and we get 5, so 7 sides, which makes it a heptagon. Now let's talk about the exterior angles. Now, we'll talk more about this on Monday, but the sum of the exterior angles, if I look at this, I've got a triangle, a quadrilateral, and a pentagon with all of the exterior angles filled in for you. And notice that each set adds to 300, or sums to 360 degrees. You can say it either way. So the sum of the measures of the exterior angles of any polygon is always 360 degrees. So let's recap what we've talked about. How can we tell how many triangles can be created by the diagonals? We know it's the number of sides minus 2, and that's the information we use to get the sum of the interior angles. 180 degrees per triangle times number of sides minus 2 tells me the number of triangles, and the sum of the exterior angles is always 360 degrees. And all of this information should be in your green book. Okay, so let's practice some problems. It says find the sum of the measure of the angles of each polygon. So an octagon, 180, 8 minus 2 would be 180 times 6, which gives me 1,080 degrees. Okay. Do these along with me, please. A dodecagon, remember, has 12 sides, so 180, 12 minus 2, which gives me 10, and 10 times this would make it 1,800 degrees. A decagon, 180 times 10 minus 2, which would be 8 times 180, which gives me 1,440 degrees. Okay. Take a break for a minute and try the other 3, and then we'll come back together. Just go ahead and pause the video. A 20-agon has 20 sides. 20 minus 2 is 18, times by 180 is 3,240 degrees. Make sure you're putting that degree sign on there. 1,002-agon, I think that one would be very hard to draw. It would be 180 times 1,002 minus 2, And a pentagon would be 185 minus 2. And I'll let you go ahead and fill those in. Let's move now to finding the missing angle. So let me pull this in a little closer, see if you can see it a little better, but it should be on your paper for the L's. There we go. So this one has 1, 2, 3, 4 sides. So we know the total is 360 degrees. And from that we're going to subtract the ones we already know, which is 120, 85, and 53. So 120 plus 85 plus 53 is 258. We're going to subtract that from 360, and we get 102 degrees. Okay. Go ahead and try the rest of these with a partner in your class. As long as you're doing what you're supposed to be doing, it should be fine. You will have a quiz over this. I will let you use your green books for it, but you will have a quiz over this on Monday. Please make sure you have it all written down.